Hello everyone, I'm Tim Bird, and I'm the core maintainer of a test system called Fuego. And today I just want to give a brief introduction to Fuego, some of its major features. We had some meetings yesterday. Some of you have seen some of these slides already, but that's okay. I'm just going to go through them. And we'll talk about kind of the vision behind Fuego, what are some of the things that it does, and architecture, and a little bit of roadmap looking into the future. So just to get started with the vision is that as if you came to my keynote on Tuesday, this slide should look familiar, but the vision is to do for testing what open source has done for coding. Really I want to promote the sharing of tests, test methods and results the way code is shared now. And the interesting thing about that is there are some things that are not shareable because we don't even have artifacts for them. And I'll describe a little bit of that, but I want to make it really easy to create, share, and discover tests, and make it easy also not just the tests, but the results. Have federation of result values so that we can do better as an industry. So Fuego is a test framework focused on tests and test reuse. So it has a lot of mechanics because it also, you have to trigger jobs, execute the jobs on target, but the primary focus is really on the tests and the artifacts around testing. And so I'll talk about the major elements. So Fuego has about 5 major pieces. The first is a Jenkins interface, the text execution system itself, which is kind of the core of Fuego, a bunch of prepackaged tests, the Docker container, and a test distribution. I'll talk about each of these. So Jenkins is a continuous integration system. If you're not familiar with it, it's been in the industry a long time. There are literally thousands of plugins. In the Fuego system, this is a layer of our code that handles job scheduling, notifications, and visualizations. And a lot of the, so Jenkins is used to actually launch the test jobs, and the user has to configure those triggers themselves. It shows the test results. We wrote a plugin for Jenkins that does plotting of benchmark results, and we also shows some HTML tables of results. And like I said, it has a very large ecosystem of plugins that already exist to do email notifications, other kinds of plotting, and it's integrated with other source code management systems, so you can set up Git triggers or SVN triggers. It's kind of too big of a system to describe in detail here, but this is a little bit what it looks like. You basically, I'm going to zoom in on this in a second, but what you do is from the Fuego core, you take a test and you create an object for that in the Jenkins interface. And then that object associates that test with a board. And so a Jenkins node or a slave is kind of the equivalent of a board in your lab. And a Jenkins job is equivalent to a Fuego test. And then I already mentioned that Fuego has a custom plugin for plotting. So this is a closer look at the interface. We intentionally try to limit the number of plugins that we deploy on Jenkins because, one, to make it easier for us to migrate between Jenkins versions. Jenkins has a nasty habit of obsoleting their own plugins, incompatibilities. And so this is a very kind of boring interface. You can add all kinds of plugins that do kind of nicer interfaces for organization stuff. But it has the basic things like this is the list of jobs. In this particular case, I've got a bunch of BeagleBone jobs, Drystone, dbench, cyclic test, hackbench, signal test, whetstone. And then this is the queue. I happen to fire off a test plan job, which was kind of our equivalent of a batch job. So all these jobs are queued up, and I could look at the history as the jobs go by, see the status. These little things, have nicely colored balls indicating the status of results of the tests. So underneath Jenkins, or a separate component, is the actual test execution system. That's the thing that actually runs the test. It constructs a test environment based on data that's provided. Each test is executed in multiple phases, consisting of a build, phase, a deploy phase, a run, and a process results. There are other phases that do things like check for prerequisites or that do a test setup and cleanup. But these are the main four functions. Each of these is defined by a single function in a shell script, or it looks like a shell script. It's actually a little bit more complicated than that. In the end, what ends up running on the host is a shell script that we've constructed from lots of different pieces. And then this test also evaluates results. So one of the things that's important about Fuego is that we allow customization of the tests. Obviously, you can go edit a test, but that's not something that's easily shared with other people. So we have something called a spec system, which allows you to define test parameters. And then as a user, you can easily select one of those parameters. So if, say, you're using cyclic test to try to find interrupt latencies, you would have a certain set of command line options that go to cyclic test. That's the most common use for a test parameter, is to adjust the command line options for the actual test program as it runs on the board. Another way that we allow customization is the results evaluation criteria, or what we call the pass criteria. So one of the problems, and this is, I think, one of the reasons you don't see a lot of benchmarks results floating around, is the benchmark results are heavily board dependent and OS dependent, and even kind of configuration and what hardware you've got installed. And so you can't really ship out a pass criteria for something like a file system test that will apply to everyone. And so our pass criteria, so the thing that holds, the threshold value, what is the minimum performance that constitutes a pass in your file system, that can be customized on a per board basis, and end users can create different customization files, criteria files, based on any thing they want. They can basically hand their own criteria in. So if they're doing like a phone testing, they might have different criteria for file system performance than they would for a server or something like that. But I think it's really important because being able to customize that is really critical to be able to share the tests. And then we also have customization. You can customize Fuego at the board access layer and at the platform management layer. So both of those are what we call overlays. So we have a set of functions. In the case of the transport layer, we have functions for getting and putting files to the target, executing commands on the target, rebooting the target, and what's the other one? Command, OV transport, get, put, command. I can't remember the last one. But anyway, there's 4 main verbs. Anyway, and so that can be customized. So we support serial, SSH, and a couple of other transports. But you can plug in your own transports at that layer if you want. And the same thing with distro. We have distribution-specific functions. So when you want to clear the cache or you want to access the logging, those are different depending on what distribution you've got installed, and there's a isolation layer there. The other thing about the test execution system is that the test results are converted into a unified file format. So each test tends to produce its own kind of text output. Most of the time it's been optimized for human reading, but we have to convert that into a unified format to convert it into a backend so it can be visualized. So that's I think a key feature as well. In terms of tests, we have at last count we're a little bit over 150. This slide is a little bit old. But we have all these tests that are already integrated. They cover a lot of different areas like file system performance, basic syscall, and kernel performance for IPCs and things. We have memory testing, crypto library testing. We have some graphics tests, although they're a little bit, we could use some kind of up-to-date ones for things like Wayland. We have the venerable LTP. And some of these are full-on suites. I think not mentioned here is K-self-test. We have a K-self-test. So we have lots of categories of tests, and the idea is that you can get this and immediately start running these with very, very little setup. We categorize our tests into 2 different kinds, functional and benchmark tests. Functional tests are just classic pass-fail, and then benchmark tests have some kind of number that you have to compare with some other number to determine if you pass or fail. All of this is running on a, yeah. Oh, we have a mic. Can we?
Yeah, regarding the performance test, how do you compare the current data with the old data and find out like which is good or bad? So if you have a lot of data, so how you're parsing that and ensuring that you're going, the graph is going up or down?
So the parser, we have a post-processing step where a parser goes into the test log and extracts pieces of data. And for a benchmark test, usually you'll get like way more data than you can track, but you can adjust what pieces of data you pick out inside the parser. And then for your pass criteria, what you do is you define a pass criteria that says for this particular value it has to be be either greater than or less than or whatever the comparison operator is, then some threshold value. So you set up a bunch of threshold values, and those are not. We have a feature in progress to actually record previous values so that you can automatically create those criteria files, but right now you create them manually. So you would look at, if you're measuring file system performance on the BeagleBone Black or something, you'd look at the historical value and say, well, I don't want it to dip more than 10% off of that, and so you'd assign an appropriate value. We actually have a feature in flight. It's been in flight for not a couple of years, about a year now, to automatically go back, coalesce the data, and set a threshold criteria file for you. But it's not in the product yet. So
okay, no problem. Thank you.
Okay. So we do all this inside a container, and the reason for that, there's a couple of reasons. We want to avoid install issues. We have between Jenkins and our Python code and a lot of the test programs themselves, there's a fair amount of stuff that's needed on the host system, and to simplify the installation, it helps to have everything running in a container. The other thing is that we do builds of the software, the test software itself. We don't usually build the software under test, so the test image, but we build the test software like Sysbench or LTP, we build those. We cross-build those from the container, and having a container means that we have a much more uniform environment for doing those builds, so it's more reproducible for those programs. And then the last thing is, since you're running tests, our vision is that eventually you'll be running tests from third-party sources, and we'd like to keep that inside a container so it doesn't mess up your host system. And I got to talk to you about doing it with an unprivileged container, because currently we're using, most of the time we're using a privileged container. And then Fuego itself, we also view Fuego as itself being a Linux distribution. So like I said, we have a curated set of libraries that we think are useful for testing purposes. So for instance, we have ImageMagick and Selenium are installed by default. Well, not anymore, but you can install them, have them installed by default. But there's other things like the iPer server and servers and libraries and tool chains and emulators that come pre-installed, so you don't have to go hunt those down and figure out the dependencies that your test needs in order to run. And the goal is to curate this stuff so that test developers don't have to do that curation themselves. In terms of architecture, it's very much what I refer to as a board at desk architecture. So it's not a big scaled up thing like Lava. Lava has a lot of great features with distributed architecture. This is much more single host connected to one or more target boards, usually a small number of target boards. And so we have a host machine and the target board. They're usually directly connected with serial and then on the same network. And then we have a Docker container running on that has the core, Jenkins, the build system. A lot of the artifacts are volume mounted back out into the host system. So as a developer, you don't have to stay inside the container to be working with the materials. You can do the operations just from command line at your host, and you can go CD into a directory, look at logs and stuff. It's all local. Since Jenkins provides a web interface, there's a web control interface that allows you that you can export to other people if you want. So as I said, it's intrinsically host target. It's also intrinsically embedded because we cross-compile the software. So we don't make any assumptions about whether you can build the test software on the host or on the target. All text execution is directed by a host machine, so our tests actually run on what we call the test runs on host, but it will do things like deploy software to the target, execute that software, collect the logs back, and analyze it. So there's no assumptions, very little assumptions about what's on the target device. Yeah. Oh, yeah.
So on the cross compilation, so you have an expectation of a tool chain that's going to be there.
Yeah,
And if you need a different one,
we have the end user install the tool chain for their board, and we have like instructions
into
for how
the
to do that.
container
Into the
itself?
container.
Okay, so
Yeah.
that's just part of the container setup.
Yeah,
process.
that's part of the user setup for their board. So usually, a lot of people when they get like a dev board, they'll get something from their vendor. Or if you're doing in-house work, right, you've got an SDK that it is associated with your board, and you have to install that SDK as part of setup for using Fuego. So
Okay.
we are actually working on a binary caching system, but there's some issues with that actually we discussed yesterday. Anyway, that's not ready yet. But
So do you then build the new container and republish it so that you can use it in different places, or do you have to do this because you can I assume you can potentially have different host machines running as
Yeah.
Jenkins workers, and how do you propagate the Docker image across those? Or is it manually out of?
That's
Fuego?
out of scope.
Okay.
So you can have multiple hosts in your lab, but we don't federate stuff. And I think there's a way to federate Jenkins, so you can send jobs from one Jenkins instance to another. But I haven't done any of that personally. I think some Fuego customers have done that.
Okay.
Anyway, so we have a very low, we strive for a very minimal footprint required on the target. Just a POSIX shell and a few utilities like cat, grep, tail. They're supported by BusyBox. There's no assumption that you need to run Python or expect is notorious because it requires PHP. And anyway, so Fuego can wrap existing test programs, or you can write your own. So we have a division of roles. We've been actually working pretty hard the last little bit to separate our layers better. Docker provides the overall build and execution environment. Jenkins handles the job scheduling and visualization, so it's kind of at the front and the end of our cycle. And then Fuego scripts do the work in the middle for executing the test and gathering results. And although our primary interface is a graphical interface through Jenkins, you can do all of our operations at the command line. So it should be amenable to be used in other environments. And in fact, one of the things we've got integrated for our upcoming release is the ability to communicate with a squad backend instead of Jenkins. So we can take our data and put it into someone else's visualization engine. Okay, details. That sounded like it was pretty detailed, and I gotta hurry so I give Carlos enough time. But I'll just go over some of this. I've already kind of breezed over. But tests are built from source, and you provide your own tool chain. We do provide some generic tool chains and some tools to install generic tool chains. Most of the time, those work. Like if you have an ARM64 board, the tool chain that we provide will probably work. We support, in theory, any architecture, although cross-compilation is always subject to little nuances depending on the architecture. So the ones that are well supported are x86, 64, ARM 32-bit, and ARM 64-bit. And other ones should work, but it's like kind of buyer beware. If the test program is a simple shell script and uses an existing program on target, like we have a test for DD, we use DD as a benchmark, and then there's no build step involved, and you can have empty steps if they don't apply to your test. And then the resulting program, when we do a build, is transferred to the target, so it doesn't have to be pre-installed. But if it is pre-installed, you can check for that in your test and use the pre-installed one. Fuego source comes in 2 repositories. Really, one is kind of the stuff that's outside the container for managing installation of Fuego, and has default configure information and default board samples, roughly equivalent to devices in Lava, and documentation. And then the Fuego core repository has the actual core engine and the tests themselves. Installation, it's supposed to be really easy, and this slide is actually old. There's one less step in our next release than there is in this release, but I decided to not deceive you. So if you were to go to Fuego today and run these steps, so basically you clone 2 repositories, you run the install script, you wait while we build a Docker image, and we're not at the point right now where you can download a pre-existing Docker image, because we do some customization of the image based on local parameters for your host, but that's something that we're definitely interested in. Then you start up that, so you've got your container running. Then you add nodes. In this case, I'm just going to add a localhost node, and then you populate it with populate the Jenkins interface with the jobs that you want. So there are some test plans that have like a list of jobs for that plan. One of them is called test plan default, and so we're going to add a bunch of jobs, and that will populate Jenkins with a bunch of jobs, including a batch job. Then you go set up the trigger on that, or you just click on it to run it manually, and go look at it in the, well, you go to the web interface to do that, and stuff should start churning around. The other thing, of course, you have to do is you have to add your board, and that's a simple operation that I'm not going to go into the details of because I'm way over. Let's see. So I already talked a little bit about the abstraction layers. Get, put files, execute commands, collect logs, and then test variables. So you can configure the test variables and customize the test for different kind of use cases. And we call that, we call the test parameters, we have something called a spec file that holds the values for those parameters. And those can be, you can specify your own specs. So if you want to customize a test and provide your own command line options for the program, you can write your own entry in the spec file or create your own spec file and hand it into the test. So that's something that then can be shared. So if you say like, okay, so I'm using dbench and I want it to run with a certain number of parameters, and that's kind of useful in my situation, that might be valuable to someone else. So you can share that spec file with another developer, another team, and say, oh yeah, this is really good for testing, I don't know, like enterprise database or something, or versus like phone application use or something like that. So to use the existing tests, you add a board configuration file, you add a tool chain, you select the test to run, you configure the job triggers, and then away it goes. And then to customize existing tests, you adjust the test parameters, and you can customize the results processing by editing the criteria file. So like if we have default criteria files for you, so if you're running something like IO zone and your board is not meeting what we expected for the threshold, you just go in and adjust the threshold. And you can adjust those on a per board basis. Let's see. Since I'm running really low on time, I'm going to skip all the way to the roadmap. So where are we going? And this hopefully will give you a little bit of our thinking in terms of vision. There's a bunch of things I don't want to have to do in Fuego, which is one of the reasons I'm here. So I don't want to do email-based patch CI triggers. I'd rather not do provisioning. I'd rather hand that off to some other layer. So Lava is a good candidate. But we'll probably add some of our own provisioning just so that we have some support there. But if we don't have to manage a whole lot of complexity, that'd be great. Board control drivers and lab management software. I don't want to write lab management software. I don't want to write the centralized results repository or the distributed results visualization. Other people who are better than I am can work on that stuff. What I want to focus on Fuego is the repository of test definitions, the generalized output parsing system, and sharing of past criteria and test case documentation. So the thing, Dan, you were talking about the annotations. I think that's really interesting, and I want to talk to you more about that. So what's coming up? So test definition improvements, modularization, more tests, central server for sharing tests, and interoperability with other systems. Okay, you'll notice that a couple of those actually are contrary to what I just barely said we're not going to do. But you kind of have to anyway. So we're replacing our test plans. Our test plans right now are serialized, and we're replacing them with they're essentially, well, we're replacing with a system that will allow for more complex pipelines, that will allow multi-threaded concurrent tests to be running simultaneously, so you can do things like set up a monitor and run a test and do a stress at the same time, and also have conditional aspects to your pipeline. We'd like to migrate towards a standard test definition format. Of course, that would require that there was a standard test definition format, so that's another reason why we're here this week. Support for provisioning. Modularization, we've been trying to separate pieces of Fuego so that they can be used by other systems. Two pieces that we're really interested in are using other job scheduler, well, 3 pieces. Using other job schedulers, possibly like Lava, things with results visualization, so using a different backend like Squad, and then creating a standalone parser. Also, we want to do a bunch more tests. I'm personally interested in testing LTS kernels, and then we also wanted to do a central server for sharing tests. And I do not have time to go over my server concept. It's a really great one. What?
We'll take your word for it.
It's you can read the slides. Slides are wordy enough. The idea is that what I'd like is you to be able to submit a test kind of to the cloud and have a Fuego node pick it up and run it locally and give you the results back. So it's a lot like people do, but it's basically kind of one at a time. Create a virtual distributed lab with like 10,000 nodes and automated routing of test requests to appropriate nodes. And then the other thing, we want to do interoperability. So we talked about the PDU standard yesterday. We want to talk about external hardware APIs, so APIs to power management, to PDUs, reusing tests from other systems, and exporting tests to those systems. And then we have this long-term thing we've been working on, documentation, for a long time, and so we just need to get cycles for it. Okay, we're going to keep working on this stuff. I'm over time. I'm really sorry. There's no time for questions. Catch me in the hall. Thank you very much. There you go for stuff.